What's up, guys? So today we're gonna evaluate learn something called L'Hopital's rule. And the deal with L'Hopital's rule is, even though they teach it at the end of a course, I don't see a need just to plop a lesson at the end of a course. I feel like this could really be taught at the beginning, because it's kind of related to, it's in a way related to the limit, like trying to find a limit that might or might not exist. But this is something obviously that you need actual calculus to do. So let's get started. It's called L'Hopital, and as I said, we're learning L'Hopital's rule, and it basically says the limit as x approaches a of f of x over g of x becomes like 0 over 0, infinity over infinity, or sometimes it's not necessarily f of x over g of x. You can still get something like infinity minus infinity, or 0 to the infinity, or it can be some whack expression. And the thing is, this is very ambiguous. I don't know if my answer is if that's like some number or whatever. So we're gonna have to apply this thing called L'Hopital's rule. And L'Hopital says this equals limit as x approaches a f prime of x over g prime of x. So you can in a sense take the quote, take f prime of x over g prime of x, basically as x approaches a. If f of x over g of x gives you an ambiguous answer, and you keep on doing this, and you can keep on doing this if you get ambiguous answers until you get to the point where f of x over g of x is an actual number. Until you get an actual number, it can be 0, it can be infinity. I mean, it can be 0, it can be like some positive or negative number, or it can just really not exist, like you're going to infinity. So let's try this example. It's pretty hard, but let's always evaluate first. So we're gonna get 0, because 0 squared times e to the 0 over tan squared 0. So this is just a 0 over 0. And this means we're gonna have to apply L'Hopital's rule. So we have f of x on the top and g of x on the bottom. So let's try this again. Don't worry about the problem I'm boxing in. Just worry about this thingy. So f prime of x over g prime of x. Always say the limit as we're going to 0. It's going to be 2x e to the x plus x squared e to the x. Remember your product rule. Over 2 tangent of x times secant square of x. Because you must remember your power rule. I mean your chain rule in this case. Because the derivative of tangent of x is not 1, secant squared of x. And let's try this again. And by eyeballing it, you might see 2 times 0 times e to the 0, which is 1, plus basically 0 squared, another 0. And on the bottom, you have 2 times 0 times 1. And basically, come on. We're getting another 0 over 0. Are you freaking kidding me? For goodness sake. No. Well, what we have to do, L'Hopital again. And let's go. Alright, everyone. So it's f double prime of x over g double prime of x. And what we get is 2e to the x plus 2x e to the x plus 2x e to the x plus x squared e to the x. If you don't know the derivative of e to the x, it's essentially just e over x. So at the bottom, we get 2 secant squared x plus 2 tangent of x times secant squared of x is just 2 secant tangent. Now, I know this is getting a mess, but you don't really have to simplify it. 'Cause look what we have top. I plug in 0 for x, only the first express term, 2e to the x, will get me a 2. Everything else is just 0. And at the bottom, remember secant squared x is 1 over cosine x squared x. So secant squared times secant squared is secant to the 4th, which is 1 over cosine to the 4th x. 1 over cosine to the 4th of x is 1, so 1 over that is 1. And 2 times 1 is 2. What we got later is tangent of x is 0, so 0 times whatever blah there is 0. So we get 2 over 2, that's 1. Phew, that was tough, but we got through it. And next up, we're going to try this thingy over here. So as always, plug it in and try it, because you never know that they're going to throw you something easy. So we get 0 to the infinity. It's very ambiguous. And before you be like, well, how will we simplify this? Well, take ln. You can do log, but just do ln, because ln is so, overrated, I guess, in math. So, yeah. So, ln of 1 over x over x. Well, you're gonna take ln. So 1 minus x to 1 over x, we're gonna say is a, basically. Now we're taking ln of a. In this case. So let's evaluate this thingy. And we get good old ln of 1 over 0, which is 0 over 0. So that means it's time to apply our good old friend L'Hopital. Now limit as x approaches 0. We're going to take this derivative of, we got f of x on the numerator and g of x on the denominator. So we're going to take f prime of x over g prime of x, which is 1 over 1 minus x times negative 1, obviously, and that over 1. And let's see what we get. Negative 1 over 1 minus x. Plug in 0, so we get negative 1. So ln of a is negative 1. That means a is e to the negative 1, or 1 over e. And right there, we got our solution. And finally, because I don't want to teach you just a bunch of random facts that probably won't do any good, I'm going to actually prove L'Hopital's rule. And this is a really simple proof, but you could probably even do this on a test if you forget. So limit as x approaches a of f of x over g of x. So x is basically approaching a on this expression. And how will we get? And let's say this is 0 over 0. Well, here's the thing. If f of x equals g of x, then basically